Hello everyone and welcome back. This is Mr. Keeney again, and we are continuing Unit 3 notes today. We are diving into our first special quadrilateral. Now, a quadrilateral is a polygon that has four sides, and today we are talking about a parallelogram. So we're going to be talking about parallelograms. What is it? What makes it a parallelogram? What is its properties, and how can we use those? So as we further discuss this unit in parallelograms, you'll see that there's a lot of different kind of ones that I'm sure you've heard of, like rectangle, rhombus, square. But today we're just going to be talking about the broad parallelogram. So let's just start there of what and how do we find define a parallelogram. So, that's not what I wanted. I want a little pencil. So I'm going to start by just saying it is a quadrilateral, which again is a four-sided polygon. And it's a quadrilateral with both pairs of opposite sides parallel. I hate it when I have to write so much. Okay, so when we take a look here, what makes it a parallelogram is if I look at the picture, both pairs of opposite sides are parallel. I've highlighted the little arrows to kind of show us that right there. So the arrows means they're parallel, so we know that they will be a parallelogram. So we're going to go through. A parallelogram has, I believe, 4 or 5, I might be including the definition here, special things about it that we're going to use throughout this unit. So we're going to go through these different theorems and just talk about what are the properties of a parallelogram. So the first one here, if we have a parallelogram, which over to the right you see that is a parallelogram, then we know that opposite sides are congruent. So not only are opposite sides parallel, but opposite sides are congruent as well. So when I look at this picture here, QP would be congruent to RS, and I believe this should say QR. Let me change that here. QR will be congruent to PS. So the opposite sides are congruent. That's why they have the tick mark. So that's the second thing we know about parallelograms. Opposite sides are parallel. Opposite sides are congruent, so they're the same length. Moving on here. So we're going to go over to theorem 8.4, which you don't really necessarily need to know the names. This one is talking about a parallelogram too. This is saying opposite angles are congruent. Not only are opposite sides congruent, but opposite angles are congruent. Again, we're talking about the angles here. So you'll see with the arcs that angle P is congruent to angle R, and angle Q is congruent to angle S, and we're able to see that with our number of arcs here. So a lot of structure in these parallelograms, which is good. It's going to make, as you can imagine, these algebra problems coming up very simple. Another thing about the angles, consecutive angles, so the ones right next to each other, are supplementary. Oops, I keep doing that with the highlighter, supplementary. So what does this mean? Well, if I were to look at X and X, first of all, they're opposite angles, so they're equal. And then Y and Y, those are equal. But what's really big here is if I had to take X plus Y, it can be kind of like in any order because it can go like this way, it can go this way, and it can go this way, and last but not least, I guess it's just this. Either way, if we look at the consecutive angles right next to each other, it's always going to be X and Y. And so consecutive angles are supplementary, meaning if I take X plus Y, I would get 180 degrees. So that is our third kind of thing that we're learning so far to add on top of opposite sides are parallel. That was kind of the definition in the 3 things. Opposite sides congruent. Opposite angles congruent, consecutive angles are supplementary, and then we're going to talk about the diagonals here. The diagonals bisect each other, which bisect is a word maybe we haven't heard lately. Bisect means to cut in half and make 2 smaller and congruent pieces. So notice these diagonals here, and maybe I should start by talking about diagonals go from corner to corner. So like this one right here is a diagonal, and this one right here is a diagonal. I'm sure you guys knew that, but I just wanted to make sure. And you'll see that these diagonals are being cut in half. They're cutting each other in half at point M. So when I'm looking at this, QM would be congruent to SM, and PM would be congruent to RM. So diagonals bisect each other, and now we're going to use these to do a little bit of finding and solving. So We are given a parallelogram because opposite sides are parallel. They want us to find the opposite or the values of x and y. When I'm looking at x, we'll start with x. X plus 6 is here, and I notice its opposite side is 13. And friends, remember that we know in parallelograms, opposite sides are congruent. So x plus 6, that side, has to be equal to its opposite side, 13, and that's the equation we were looking for. So now I'm going to take away 6 from both sides, and I get x equals 7, so not too bad. And then I'm going to take a look at y. Now y, right here, and I look at its opposite angle. So opposite angles in a parallelogram are congruent. So y is pretty simple. This was x, and then y is just equal to 68 because opposite angles in a parallelogram are congruent. All right, moving on to the next one here. Gates A's. All right, I'm not sure what's supposed to be saying, but there's a gate down there below. A gate contains several parallelograms. So basically that ABCD is a parallelogram. Find ADC when DAB is 65. Now let's label what we're trying to find and what we know. ADC is what we're trying to find. ADC, I'll put a little question mark. ADC would be this one. And then DAB, which would be up here, is 65 degrees. Now remember, when we're talking about if I'm trying to find that, and this is its consecutive angle, and maybe we should call this x, those have to be supplementary. So x plus 65 would have to equal 180. Consecutive interior angle, or not consecutive interior, but those are actually 182. We learned that back in Unit 2, Part 2. But this is consecutive angles of a parallelogram. They also must equal 180. So basically, I'm just taking away 65 from 180. Canceling those out to get x equals 115. And just to make sure we're good here, the measure of angle ADC, because that's what they're asking for up here, is equal to 115 degrees. All right, and then I believe this is the last one. Yes, it is. Okay. Given that this is a parallelogram, find MH and FH. So let's just look at where MH is first. MH, okay. Now I'm noticing something here. They give me that this one is 5, and this is a parallelogram, so diagonals bisect each other. Here's the middle of the diagonals, so this piece must be the same. So this is 5 as well. So MH is equal to 5. And then if I want to find FH, which if you notice is just this whole part, well, I would do 5 plus 5, which is 10. So FH equals 10, which is actually the one we wanted to find. So this would be our final answer for that one. So that is about it for today. Just a little intro to what a parallelogram is and what are their properties. So if you guys have any questions, let me know, and I'll talk to you guys later.